back to the good old days again. Good day, everybody, and welcome to another week of e-learning. And so we're kind of to the midway point in this last week of April, and so we have a lot of things to get through today. Mondays in class, remember, used to be very busy. We had a lot of papers to pass back. Well, we're not passing papers back, but we are going to have regular old logic problems this week that I'm going to give you hints to, and we have a couple opportunities for competitions. One is we are in the final four, and we'll get you a finalized date on that. But if you look, we made it to the final bracket, and we made it through round 1, round 2, round 3, round 4, and then there were 4. And you notice that one of the teams left in the 4. I don't know if they entered twice and split their team in half, but there's 2 of them, and so I don't quite know how that works. Hopefully it's all above board, but we'll see. And so make sure that we're ready for that. And so it might be this Friday. We'll let you know. And then also we have, if you look, there's going to be an academic Super Bowl competition that's going to be individual. And so if you would like to take that, if you click on the link, it will lead you to the syllabus of everything we were supposed to cover. Now, we've covered a lot of these things. Probability was 50%, but then exponential functions, we never got a chance to practice those and to review those. And so if you want to, you can go on Khan Academy, and you'd have to look under Algebra 2 and go to exponential models. And also there's one called, now I lost it, but exponential models, and then figuring out what this constant E is. And exponential models here, and then more exponential models here on how to construct exponential functions. And so rational exponents and exponential functions. And so just look at the syllabus here, and then I will give you more information on Wednesday. I think we can start taking it individually. It'll be a Google form. I think it'll be 30 questions. I think you'll have around 40 minutes. You can use a calculator. And then the last thing is on the academic Super Bowl competition is functions. Identifying if it is a function, if it passes the vertical line test. One-to-one functions we don't talk about too much in Algebra 1, but those are the functions that are a function and the inverse is a function. So not only does it have to pass the vertical line test, it has to pass the horizontal line test. And so knowing what the domain and range is, parallel and perpendicular lines, slopes, y-intercepts from data, and function notation. And so we should feel good about this stuff. Even pre-algebra, we're starting to cover this. And then the probability things, the only one we would be, oh, there's Kaya. Hello, how are you? And so the only one we'd be a little shaky on is the exponential function. So if you're serious about taking this, you might want to brush up on that, and I'll get you more information and get you the link. And so I did know, I got an email that when we do compete, you want to pick Northridge Middle School of Middlebury, Indiana, because there is another Northridge Middle School maybe in Crawfordsville. And so you might have to ask Lincoln and Kirsten about that, Crawford. But otherwise, we'll pick Northridge Middle School of Middlebury, and we should be good. So that's coming up this week. And we have a good chance of doing really well because I see Discovery didn't sign up. So we can get this. And so make sure we'll participate. And so let me know about that. And so we have that. We have the 2 competitions. Make sure you take attendance. Most of you are. You need to get into a routine. And so I get up, I do certain things in order. I see some of your routines like 10 o'clock at night or sending me homework at 12:02 a.m. And so not a good routine. Good routine. Get up, get these things done, get dressed up, and I'm ready to go. And so get into a routine. We have several more weeks of this. 5 more weeks. 5 more weeks at 12 a.m. is not good. And so we need to make sure we have that. Email me. Let me know. I'm going to get grades in the Power School. And so we want to get all that done. And so make sure you let me know if you need anything. So you will notice this week Whether geometry, algebra, pre-algebra, we got logic problems number 31, and we want to give you some hints on these. And so just like good old days, and where I used to stand and teach, much better than the sitting and teaching. Too much sitting around. And so on the logic problems this week, the first ones, you're only allowed to use these numbers, a 50, a 20, a 10, a 5, a 2, and a 1, all of which used to be denominations of coins. For all of you numismatists out there, there was a 2-cent piece and a 20-cent piece. In fact, the 2-cent piece was the very first coin to ever say "In God We Trust" on it during the American Civil War. I think it was 1864. And so, but you can only use these 6 numbers, and you can use them as many times as you want. And you got to get the rows and columns to add up to the numbers I gave you. So if I say this row adds up to 110, you can only use 50s, 20s, 10s, 5s, 2s, and 1s. If this column adds up to 111, this column adds up to 13. And then we need to know where we're going to place these. Well, first of all, if you're going to use all 20s, 20, 40, 60, 80, you wouldn't get to 110. So you need a 50. And if I put a 50 here, you know the 50 can't go in the 13 column or the 11 column. It could go in the 82 column. But look, if I did 50, this would be 20, 40, 60, and that'd be 110. But you can't even use 20s in these columns. So that means I'm going to need another 50 right here. And I know those are both 50s. Well, if that's a 50 and the other one's a 50, I need to get to 10. Well, the one way to get to 10 is 5 and 5. Can't do 10 and 1, can't do 2 and 2, so pretty much this is going to be 5 and 5. And I know this right away. Then, if I go 13 here or 11 here, that means these 3 have to add up to 6. And that means the other ones have to add up to 8. Those are adding up to 6. These are adding up to 8. And so, but I'm going this way, and I'm adding up to 6. Well, I know in this column right here, to get to 6, you can't do 5 and 1 because you can't use zeros. And so the only way to get to 6 would be 2, 4, 5, 6. 2, 2, 1, 1. Of course, I don't know the order of this. Now, to get to 77, 20, 40, 60, see, I need a 50 in this. And the only column that could have a 50 is this one right here. Would have to have a 50. And then the rest of this would add up to 27. Well, to get to 27, it'd be a 20, a 5, and a 2. We can't have a 20 in this column, and you can't have a 20 in this column, so the 20 is going to have to go here. And then this is either going to be 5, 2, or 2, 5. Well, it can't be a 5 here because you'd have to have more than 1, so this would be a 2, and this would be a 5. And then here I need a 12 because I already got 70 and I need a 12. Well, I can't put a 10 here, so the 10 would have to go here. And then this would be a 2. Well, then if I got a 10 here, then this is a 14. Well, how in the world are you going to get a 14? Well, that'd be a 10, 2, and 2. Well, you can't put the 10s in these columns because this would add up to too much. So this would be a 10. And then this is 50, 100, 110. There's my 1. 10, 12, 13, 5, 7, 9, 11, and I'm done. And I just did one for you. You write it down. You send it in. I even said due Saturday. Some of you are like, when exactly are the logic problems due? They're due at the end of the week. If you send them too late in the weekend, I won't get them in the Power School maybe for another whole week because we'll get the grades in. I have a bunch of grades I've graded, but I need to put them in Power School, which is going to happen after all these videos are made and answering your emails. And so if you don't get them in soon or right away, it might not make the first cut. And then it sits in the pile till it gets into the second cut. And so the best thing to do is get stuff in as soon as you can. Okay, so you have 3 more of those. And then down here, I have 2 more questions for you. One is you're using the numbers 1 to 20, each of them once. Most of these squares are going to be empty. On this one, you're only filling 2 squares in each row and column. And so these things are going to be mainly empty. There'll be 2 in every column, and there'll be 2 in every row. Now, how do I know which ones? We are going to write the numbers 1 to 20. I should have typed them out, and then you could cross them off as you used them. But you could do that. You could just write 1, 2, 3, 4, 5, all the way to 20. And you want to cross them off as you use them. And so this is called product pairs. Give me a pair of numbers, and I'm going to get each of these. Well, some of them have more than once, like 48 could be 6 and 8. It could be 12 and 4. It could be 16 and 3. All those are under 20. So you don't start there. You pick a number like 15. Well, that'd be 1 and 15 or 3 and 5. Still too many possibilities. But then here, this is 11 times 12. And that's the only possibility. 170 is 17 times 10. That is the only possibility. Ooh, 17. You know, a lot of numbers 17 doesn't go into. And so when I look down here, wait, this 34 is 17 times 2. So then I know the 17 goes right here, because it goes into 170 and it goes into 34. When I look down here, let's look for 11. Does 11 go into 48? No, 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 yes. So 11 goes right here for the 209. Well, 11 goes into this how many times? It goes in 19 times. Well, which one of these numbers does 19 go into? 48? No. So then I know there's no number here. Does a 19 go into 28? No. Does 19 go into 52? No. Does 19 go into 133? 19 times 7. I think. Yeah, and so that'd be a 19. And then you know the rest of this column is empty, because you have your 19, your 11. And you could circle the 19 and the 11. And then you figure out where the 7 goes. 7 go into 34? No. 48? No. 60? No. 105? Yes. 7 times 15. 7 go into 90? No. 7 go into this? Yes. 7 goes into this 4 times. But can we use a 24? No. And does 7 go into... No, so you know the 7's right here. 7 times 19. And I better stop before I make a mistake and somebody email. You gave the wrong hint on the logic problems. And then you'd cross off this whole column. Okay? Then, for the very last one, we'll move myself to the other corner. Whoa. Maybe we'll move up here. And it says, outline the greatest number of squares of any size such that the edges do not touch. And there's lots of squares here. And then you got to count them. And I got to be able to see it when you scan it. So for example, you can't outline this square and then outline this one, because those touch. And so if you're going to outline this one, you can outline this one because those don't touch. But then this one touches this one, so then you wouldn't be able to use that one. But if you don't use that one, you could use this one. But it says the squares cannot even touch at a single point. What is the maximum number of squares that you can get? Because sometimes picking a square outlines. Now this square is fine, and then picking this one. Because even though it's inside, they don't touch. The edges do not touch, not even at a single point. So you need to find the maximum number of squares. Show them and write it right here to get all the points. Okay? So we got logic problems this week. We got those competitions coming up. And so make sure you print these off. You can send them to me at the end of the week. And so just trying to get back to the regular old logic problems. And so we're going to get to that. And then time to start the notes. Okay? Just like back in class, we got lots to do. And the sun's coming up and we got lots. Okay? So let's go back to our agenda for today. Okay? And see what we have in store for pre-algebra today. And so we're going to continue talking about lines, but we're going to come up with a shortcut today, what they call slope-intercept form. And so we're going to focus on that. And so the notes and the assignment are all right here. And make sure you're working on the Khan Academy stuff. But some of that you won't be able to do because we're going to learn it today, and then you can work on it. And so we'll post the video here once we're done. And so, but before we start with the notes, I just want to take someone's homework because bad thing about this, many bad things about distance learning, but one thing is you can't ever get your homework back, and well, not anytime soon. And so when you look at it, but I am grading it, and so you need to be aware of that. So here's someone's assignment. This was a good one, and we want to look at this and look at some shortcuts, because today we're going to graph these lines and we're not going to make any charts. And so how are we going to do that? And so if I look at these problems, notice, we're going to zoom out a little bit. On the front side of this paper, which ones go uphill? That means they start low and go high. So like this one goes uphill. And 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 this one goes uphill. Now look at all these problems. And what do you notice about all the numbers that are in front of the X on all the ones that go uphill? What do you notice? Gloria, since it's your great work, great job. What do you notice on your assignment? Did you notice this before I brought it up? That all the numbers in front of the X are positive and they go uphill. That means the two that I didn't highlight, they go downhill. They have a negative number in front of them. Oh, they do. Oh, interesting. Very interesting. Now, what else are some things we could notice on the front side? Some of these lines actually go through the origin. What's the origin, Josiah? Oh, yeah, that's where the X and Y axis cross. So, Layla, which ones go through the origin? Problem 7 does. Problem 8 does. Problem 11 does. Problem 12 does. What do we notice about these problems that go through the origin? What do we notice? Pause, time, think. What are you noticing, Lucas? There's no plus or minus. There's only like the 2x. There's not 2x plus 1. It's just negative 3x. It's not negative 3x plus 7. It just has the x term. And it goes through the origin. Oh, very interesting. Very interesting. So what do you mean? If that second number is a 1, where did this cross the y-axis? It crossed at 1. Whoa! No way. Oh, man. This one, negative 1. Where did it cross? Negative 1 on the y-axis. This is the y-axis. See, that had a 0. This had a 0. This one has a negative 8. I bet you I knew where it crossed right there. Negative 8. Man, this is going to be the greatest thing since sliced bread. I'll tell you. And this one, that I don't know where it went when I sent the homework, but Gloria wrote it in. So the plus 7. And so that crossed right there at 7. Excellent. You think this works on the backside? This would be a lot faster than making a chart. You know, this is e-learning. Mr. Nison's videos, even when I watch them at 1.5 speed, you know, they go on and on. And so I just think I have all day. There's no bell ringing for me to leave class. You can just keep talking. Let's see if the shortcuts on the backside work, because these last 4 would have had a lot easier. I had trouble, Mr. Nison, with problem 22. But if you would have told me that if it crossed at 1, that's just a plus 1. Whoa! Why didn't I think of that? This crosses at 4, and that's a plus 4. This crossed at 0, that's why there was nothing here. This crossed at 0, that's why there was nothing here. This crosses at 2, and lo and behold, there's a plus 2. Hey, boo-boo! I think we get this done, then we can go get a picnic basket. This one crossed at -1. This one crosses at -6. And this one crosses at +3. Man, why didn't you tell me this last week? You didn't ask. And then, wait, what about the negative? This is a negative number, and it goes downhill. This was a -3/4, and it went downhill. This was a -2x. It went downhill. This has a -2x. It went downhill. And then notice, these were both -2. And these lines have the same steepness about them. Ooh. And this one up here also is a -2. And it also has the same steepness. You always want to observe things. The cats are sitting in the window right now. They're observing the birds. But they're glad they're in the house. And so they're pretty spoiled. And so you always want to observe. And then, so I pretty much already taught you all the notes. Okay? So you always want to not only do your homework, but after you do it, reflect upon it and go, is there a better way? I wonder if there is a better way. And so, I know the sunshine in here is like making me look like I glow or something. But hopefully that doesn't bother you too much. Okay, so let's get to the notes, and hopefully filling them in now is going to be a lot quicker. And here we go. We are going to graph lines without making any charts. And so this is notes 118. And we have a homework worksheet tonight that we're going to start together. And so the old way of graphing this is plugging in numbers. And we would make an X column and a Y column. And then it's like, you only need enough points to figure out where in the world this line is. And so somebody plugs in 0. And you get -4. But then we realize, wait a second. If that's here at -4, that was just a -4. That could kind of tell me where to begin. And then if I plug the 1 in, 1 times 3 is 3, and 3 minus 4 is -1. And if you plotted the point 1, -1, that would go right here. But then if you kind of look at it from here, if you began here, and then you went to here, how many squares did you go up? 3. No way! Really? How'd I miss this? Then if we picked a 2 and plugged it in, 6 minus 4 is 2. The point 2, 2, not a 2, 2, is right here. Is that up another 3 squares? Oh, man. You mean if I plugged in a 3, it'd be 5? You think so? 3 times 3 is 9, minus 4 is 5? And I could have just looked at these two numbers last Friday. I'm really getting upset about you not telling me this. That homework took way too long, plugging in numbers. And you know, one of them, I actually got this little box answer, didn't even make a line. You know who you are, who did that. And it should have made a line, and that would have been, oops, I think I made a mistake. And so, and then we plug in, and the 3 tells us how far apart. And so we're going to begin, and then we're going to plot these points without ever making a chart. And we can plot as many as fit in the line. And then we're going to get our straight edge out, and you know who you are. And you got to connect the dots. Seth, make sure we're connecting the dots. Not just dots, but connect them. And Katie, make sure we put arrows on the lines. And you got it. I know you said, I'll remember. And I know you will. And so, but reminders are good. And so I put a string around my finger to remember something, but then I couldn't remember why I put the string around the finger. So yeah, it just didn't work. So now let's go to the next one. We'll move myself over here. Here we go. We don't want to make a chart. Just not gonna do it. No, 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 no. Because all I need is that little piece of information right there. Because the number that's not with the x tells me where to begin on the y-axis. That's pretty quick. And then this number right here is going to tell me how to move. Move a fourth of a square. Ugh, I don't want to move a fourth of a square, but that's really what you're doing. And if it's negative, you're going downhill. And so if I'm moving a fourth of a square, every time I move a fourth of a square. So every 2 squares, I move half a square, and then 3 squares, I move 3/4 of a square, and in 4 squares, I move 4/4. So I actually moved 1. And so I'm actually going down a fourth of a square every time, but nobody in their right mind wants to count fractional parts of a square. Well, if you're going down a fourth of a square every time, it's like you're going down 1. Here, I've got to click the new mouse thing. That's like you're going down 1 for every 4 you're going over. If you're going down a fourth every time, that means you're going down 1 for every 4. And so you would just plot the point down 1 over 4. And then down 1 over 4 is a lot better than going over a fourth of a square. And then you could plot them over here. But remember, negative slopes go downhill. And some of us are going to do that backwards. And so we got to discuss all that before you turn me off. And so, and then you make your line, Seth. Line. Woo! And then make sure you put the arrows on, Katie. And then we have that. And Mikey, straight edge. Straight edge. You know, anything straight, and then line it. Okay? Now, let's write this down. Here we go. Here are the shortcuts. We have a formula that is called y equals mx plus b. It's even painted on the lobby outside the cafeteria if you've ever seen it. Well, I got words on my face. We got to get the sound off my face. Okay. And if you've ever seen that, well, now it's like, I always wondered what that meant. The M stands for our slope. And slope is how steep your line is. Your slope is it really sloped or not so sloped? This is zero slope. Horizontal is zero slope. Undefined, you don't hit the slopes. Gloria, we don't ski on cliffs, okay? And I wouldn't ski on this, but you might if it was really steep. But, you know, I'm more like cross-country skiing. And so the slope is how steep your line is. The slope is always the letter M because Descartes, René Descartes, not Descartes, was French mathematician. And in France, the word for slope is monter, which means to climb. Climb every mountain, ford every stream. And slope is rise over run. I've heard people say that before. I never knew what they meant. But now I know. It's rise over run. So slope, whoops, right there is rise over run. And so we have the slope. And then we have B up here. If we go back here, is the y-intercept. And this is where we are going to begin. And your slope, which is M, is how we're going to move. Okay? So on your homework tonight, you're going to put 3 problems on 1 graph. Okay? So if first thing on the homework, you're going to write y equals x minus 4, and you're going to write what is M and what is B. So Thomas, what is numbers in front of this x if we don't see one? Would it be a 0 or would it be a 1? Yes, it would be a 1. Great job, Thomas. And then what is my b? Well, it's plus b. So if it's a minus 4, the b is really negative 4. Now, just because the m came first doesn't mean we start with the m. When we graph these things, we begin with the b. We begin with the b. Now, negative 4 is either here or it's here. But which one of these is on the y-axis? Is it this one or is it this one? Ethan? Yeah, it's the one on the y-axis. We got people beginning on this one. And it's like, no, don't do that. Because I can't just tell you, stop what you're doing. Put it on the y-axis. We begin on the y-axis. And so, if your b is -4, we begin right here at -4. And so, your b is -4. Then if my m, as Thomas said, is a 1, that's how we're going to move. And so we're right here. How we move up 1? Well, we move up 1 every time, and we just run to the right. And you go up 1 every time. If it's a whole number, for every square you go over, it's just up 1. Now, if we made this a fraction, it'd be 1 over 1. And the top number is my rise. You rise 1, and you run 1. Now, don't expect to learn it off of one example. So we got more examples. Okay? And so we'll graph this line, and then it should shift back. Yay! And so there's that one. Now, let's graph this one. What is my m and b on number 4? Or not number 4, number 2. What is my m? What would it be, Alex? 3/4. Great. And then where is my b? What would that be, Caden? -4. Normally, we don't like fractions. We avoid them at all costs. But when you have a slope that's a fraction, since our definition is a fraction, it's rise over run, this is really nice. Because we begin at the -4, and then this just tells us to rise 3 and run 4. So we're right here. And from that right here, we're going to go up 3. 1, 2, 3. And you're just counting squares, and then you go over 4. 1, 2, 3, 4. And you rise 3, run 4. Then from that square, you're going to go up 3. 1, 2, 3. And then you go over 4. 1, 2, 3, 4. But this is the only dot that counts. And this one. And this one. And you could go backwards and visualize where the other one's going to be. Of course, there's infinitely many points on a line. And Owen, we can't graph them all. So that's why we put arrows on our graph. So we'll try to hit those like that. And then there's our second one. And so we got that. And on your homework, you could label this problem number 1. Problem number 2, you could color code them. And whatever you like. Next example. 3 and 4 down here. And I'll move myself up here now. Hey, we're just moving all around. I wish I was actually moving because I get tired of sitting all the time. And your parents probably want you up and moving too. So, number 3, my m and my b. If it's y equals -2x, what's my m and what's my b? Ian? What's m? Can't hear? Yeah, -2. But then what's my b, Ian? If it's plus, what number is really here when you don't see it? That's a 0. Yes, my hero. Bowtie man. And so we begin at 0. Now, what type of slope is going to be negative? We begin at the 0. Now we're going to move -2. Well, a lot of teachers would say, make your integer into a fraction by putting it over 2. No. And since slope is rise over run, we're going to rise 2 and we're going to run 1. Now, the most common pre-algebra mistake is people think, okay, I'm rising -2 and then I'm going to go left 1. No, 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 no. Because if I connected this, that line would go uphill. And uphill is a positive slope. Anything that goes uphill, m is positive. It could be steep or not so steep, but these all have positive slope. See, this slope is negative. Negative slopes go downhill, whether really steep or not so steep or super steep. Negative slopes go downhill. So when I begin at 0, I'm expecting to go downhill, not uphill. And so I'm keeping that in the back of my mind. I need to be going downhill. So this point right here is wrong. You don't go down and left. That is a common mistake. And I'm not there with you to say, stop. So I'm right here telling you, stop! See, the 1, is that a positive or a negative right here? The 1 is a positive, because if both of these numbers were negative, a negative divided by a negative would be a positive. So only one of the numbers is negative, and the other number is positive. So when we graph these, when the slope is negative, you go down 2, but you still go right 1, to the right, to the right. Down 2, right 1, down 2, right 1, down 2, right 1. That is the slope for that. And if we can avoid that mistake, we're good to go. And then we make our line with arrows. And so we have that. And so there's that one. Now for the last one we're going to do. Y equals -2. What is my M? And what is my B? What's my M, Jack? -2? Well, the M is with the X. I don't see an X. So what number would be in front of the X if we don't see it? Jack? Yeah, 0. And so we'd put a 0 there. Now what's my B, Scott? -2. Now where do we begin, Baber? With a B. Just because your name begins with Baber, we begin with B? Oh, that's where we begin, Baber. And so we're going to begin at -2. And so we begin right here at -2. Now how do you rise 0? Well, you can put it over 1. And the top number's my rise, and the bottom number's my run. I rise 0, and I run 1. I rise 0 and run 1. Rise 0, run 1. Rise 0, run 1. Rise 0, run 1. Yeah, if you have a slope of 0, that means it's horizontal. You don't want to have, like the floor of your house, you don't want to have a slope. Well, my old farmhouse, Mr. Nyson, does. You just put a pencil on the floor and it just rolls to one end. You sit in a chair with wheels and you roll to one end. See, that's not good. And so slope of 0 is horizontal. Okay? So we're going to start some of the homework together. Okay? You ready? Make sure you get a straight edge when we're doing it. Now we're ready to start. Let's go to the homework here. And so what we want to do is we're going to put 3 on each one. And make sure this is assignment number 118. Excuse me. So, guess I don't have to cover my cough because it's not going to get you. But we're going to draw 3 lines. You got to use the straight edge. And let's get started. First thing you have to do is the M and the B. So if you want to try these before I just tell them to you, you can always pause the video. But what's the M and the B for the first set of 3? What's it going to be, Ryan? What's the M? 3, and what's B? -5. Great job. For the next one, what's the M? Lincoln? A 1. Great. And the B? 6. And then what's the M and the B for the next one? What do we have? Blakely? -1 and -3. Very good. Now, how do we graph these? Well, do we start with the M or the B? Baylor. What are we going to start with? The M or the B? Baylor. And then we're going to begin with the B. So we're going to begin at -5. Then once we begin at -5, where would this line begin? Well, this line would begin at 6. So you go up here. 6. And then this line would begin at -3. So when I'm grading your homework, I'm looking for just 3 dots on the y-axis. And if there are not dots on the y-axis, you didn't really do it. But it's harder to fake your work when you're not sitting next to your neighbor. Sitting next to your neighbor, everybody's like, oh, what'd you get? Oh, it kind of goes like this. Maybe I'll just write it down so it kind of matches. Yeah, see, they're not there for you. So you actually have to do it on your own. And so we begin at -5, -3, and 6. So each one, if I begin at -5, which is down here, now I'm going to move 3. Well, if it's a whole number, you put it over 1. And so slope is rise over run. So I'm actually going to go 3 over 1. And so from this dot, I'm going to go up 3. 1, 2, 3 over 1. And the blue dots are 3 apart. Then from that one, I'm going to moving on up to the east side. We're going to move up 3 over 1. And then the next one, we're going to go up 3 over 1. And then we're going to go up 3 over 1. And then we're going to get our straight edge. And this is going to be problem number 1. And there's the first one. Then we go to problem number 2. We're going to begin at the 6. Now this one, if it's a whole number, you just put it over 1. Then we're going to go up 1 over 1. And then we're going to go up 1 over 1. Mr. Nice and I could only plot a couple points. Well, you could keep going. But you can visualize. Remember, positive slopes go uphill. There's actually a guy on YouTube called Slope Dude. When he goes uphill, it's puff, puff, positive. And when he goes downhill, it's nice, nice, negative. You know, and if we weren't watching YouTube all the time to get these videos, we might watch Slope Dude. But, you know, you're probably YouTubed out after these. And so there's problem number 2. And then we got problem number 3. We begin at -3. But here, the slope is -1. So here's the common mistake. Don't do this. Well, that means you go down and left and down and left. No, 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 because that would also be a positive slope. You would go uphill. When you have a fraction, -1, and you want to put it over 1, you don't put it over -1, you put it over +1. Because a negative divided by a positive is a negative. So that means we are not going down and left. We're still going down and right. You still go to the right, to the right, to the right, to the right. You always run to the right. Now, after you do this a little bit, a negative over a positive is really a positive over a negative. But this is my third graph. And we're saving paper. So we can fit it all on one side. And if you want to, you can call this problem 1. Well, that's actually problem 2. I better get this right. If I'm going to label them, I better label them correctly. 1, 2, and 3. Now, a couple things that you might get a little nervous about that we're going to go over. The first thing is on problem 10 and 11, I tried to trick you. Now, your warm-ups on Khan Academy, they try to trick you. And that's why I assigned them, because it's hard to go over everything. And they're like, well, what's the slope? Well, the slope is the number that's with the x. So just because we flipped it, don't get confused. You know, silly rabbit, tricks are for kids. And so don't get confused. And so the number that's not with the x is the b, and that is where we're going to begin. Now, if I begin at 6, I'm going to put a dot here so Mr. Nyson knows I'm on the y-axis, not the x-axis. And if you go up 4 over 1, it's not going to fit. I'm way up here, and I must have made a mistake. And then up 4 over 1, it's way up here. And then up 4 over 1, I'm into the date. I don't even know what the date is. I haven't left the house in weeks. And so, but when you go up 4 over 1, that is the same as going down and left, because a negative divided by a negative is a positive. And these actually fit. So you can visualize where these should go. And then you connect them. Seth. The next one, start at 3. Now we have a slope of 2, so we go 2 over 1. People aren't going to have trouble with this one. You go up 2 over 1, up 2 over 1. But then this third one, we have Xavier. What's the B? 1. Why don't you call him Baylor? B. And then, well, Miller, how are we going to move? And so if we start at 1, right here, if we start at 1, and we rise 8, and we run 9, we're off the graph. Oh, and it's okay if we're off the graph. It's okay. And so, and I can really only plot 1 point, because when you connect this to this one, that's enough. And you got it, and that's number 12. Okay? So be careful on those. And then the very end of your homework, down here, we're going backwards. If you can do something forwards and backwards, A, B, C, D, E, F, G, Z, Y, X, W, V, U, T, R, S, Q, P, O. If you can say that alphabet forwards and backwards, that means you know it. And if you can do a problem forwards and backwards, that means you know it. So this one, here's the answer. You tell me the M, and you tell me the B. Well, where are we beginning? Well, where does it cross the y-axis? It's called the y-intercept. And what would that be? Phoenix? Well, the B would be 0. Great job. And then Phoenix, how many squares apart are these? If I went up, I would be going up how many and over how many? And so what would that be? Lincoln, up 2 and over 3. So my slope would be positive 2/3. But in problem 20, my slope is negative because we're going downhill. Problem 21, my slope is positive. And then you just fill in the blanks. Instead of y equals mx plus b, you plug in for m and b. Plug it in, plug it in. So it's going to be y equals 2/3 x plus 0. Of course, you don't have to write plus 0 because it ain't there. And so hopefully all this helps. Let me know. Look forward to grading all your homework. Look forward to seeing. I'm going to try to get all the grades in the Power School. I got them all graded. We got piles of papers, and we print them off. We get them graded, and it all takes time. So if you say, Mr. Nyson, I sent that to you Sunday night late, and you didn't get it in Power School with the other grades. Well, because it's a process. We print them off Friday night, Saturday. You send them Saturday. They might not get printed off yet. And then I grade them all, and then I put them in Power School, and then we go back and start again, print them off, then try to do this. And so it matters where you're at in the cycle. So always want to send it as soon as you know you're doing it right. And so we miss all of you, and so have a great day, and let me know if you need any help. Okay, bye-bye.